This is not a microscope, what I'm showing here. It's something more universal than a microscope in the sense that this is a digital universal reader for essentially rapid diagnostic tests. Rapid diagnostic tests are tests that you can diagnose diseases like malaria or HIV or TB or sexually transmitted diseases. Literally, there are hundreds of different types of rapid diagnostic tests, and it's like a pregnancy test in the sense that you have to read it manually. But imagine that you have 10 of them working with you for different conditions, so that you want to rapidly diagnose different conditions. Then it becomes tedious, and of course you may start to make mistakes because of the control lines, and the tests of these things vary from manufacturer to manufacturer. So what we've created is actually a platform that uses the cell phone to automatically identify what test you've inserted, read it if it's valid or not, and then if it's positive or not, and quantify, for instance, the density of antigens if the rapid diagnostic test is built that way. And capture an image of this running on an Android phone or an iPhone, quantify this all through the application running here, and then with some more text that the healthcare worker may want to put in there, it sends this to actually a Google server, a secure Google Maps server, where you put there the timestamp and the geographical location. And the idea is this universal reader running on cell phones is going to collect from all around the world whatever rapid diagnostic test has been used, where, under what condition, and then you will be able to pull up statistically what's going on, which diseases are being controlled, which diseases are spreading, frequencies are and how they relate potentially to cause-effect. Maybe it's related to your policies that failed or that worked fine, and you can understand now which parts of the world are tackling it better than the others and how globally things change. That's why it's important to keep this as a universal digital reader, because once you read this test in field conditions, because of the humidity and temperature, it dies out. You can't read it again after a couple of hours in field conditions, because it's like an old photograph, it just fades away. That's why digitizing is important, because that is a single test. But if you digitize it, it's a single point, and combined with the rest of the points, it really tells you much more than a single test could. And if you can do this for various different tests, various different conditions, diseases, then you can build a phenomenal world-scale map that would be extremely exciting.